be addressing in this morning session. Ms. Askia Augustine.
Thank you, Ms. Haynes Joseph. Morning, everybody. Again, my name is Saskia Augustine, and I'm a standards officer here in the Standards Development Department. Okay, so I'll just be taking you through the background and importance of, more specifically, the standards that we will be looking at today, and very briefly too. So it started with a new work item proposal. It was developed by Mr. Vern Emmanuel. So this was after receiving complaints about the poor indoor air quality of offices, schools, and workplaces in St. Lucia more specifically. So after favorable support, the Environmental Committee began work on the standard, but they soon realized that one standard would not properly address all of the factors associated with indoor air quality. So we therefore looked at a suite of standards, which we'll be looking at in a bit. So they were all considered for adoption. So these standards would specify the requirements for identification of sources of pollutants, sampling, investigation of buildings, indoor air quality management systems, and determination of concentration of chemical agents. So the aim of these documents is therefore to control air pollutant concentrations to a level where they do not have the potential to cause a significant risk of adverse health effects and affect the comfort of the majority of the occupants. So with that, we will begin the review of the standards. The first set is the indoor air standards, and there is the ISO 16000 series. So these are just some of the standards that are included in the ISO 16000 series, and those are the ones that were adopted by our environmental committee. So the first one we will be looking at is part 1, that is the indoor air quality, general aspects of sampling strategy. And with that, we have our next presenter. She's also a member of the environmental committee, Ms. Annette Rattigan-Leo. Ms. Leo.
Thank you, Saskia, and the rest of your colleagues at the Bureau of Standards. Colleagues, good morning and welcome to this session. It is my task this morning to walk you through what is entailed in parts 1 and part 19 of the 16,000 series under this set of standards. So we'll go to our first slides where we will be looking at part 1, with respect to the general aspects of sampling strategy. So within this standard, as you can see, the contents are outlined here, and I'll just walk you through them briefly. I am hoping that persons who are interested would have taken some time to have gone through these standards, and as was indicated by our colleagues at the Bureau of Standards, to provide us with your feedback, comments, etc. So within the introduction section of part 1, for the general aspects of sampling, this will provide you some general details on the standard itself, what it comprises, and it also points you to the relevant annexes that you need to make reference to. In terms of the scope, we'll touch on that briefly because this basically brings everything that you're seeing in. It's okay, leave that slide. You can go. Cool, yeah. So basically we'll come back to the scope, but with regard to the normative references for this particular standard, there are 2. One is ISO/IEC 17025, and the other basically points to the guide to the expression of uncertainty in measurements. So these are reference standards that you need to look at when you are working or reviewing this particular standard. Within the part 1 as well, there is indication with respect to the special characteristics of the indoor environment. And basically this speaks to planning for sampling and measuring strategy that you need to be cognizant of when working with this standard. The measurement objectives basically looks at what would trigger the need for a measurement. And in terms of the sampling procedure, this provides a guide on how to get the best measurements. There are many methods that we could employ, but depending on the situation, you need to determine what you have to do to get the best measurements. The time of the sampling, again, this section, it basically highlights the importance of planning for your sampling and taking into consideration activities of any interferences that might happen within the selected space for sampling. In terms of the section on duration and sampling frequency, again here, you need to consider whether or not you're doing a short or a long-term sampling procedure, and the frequency as well, depending on the health, the potential for health effects. With regard to the sampling location, this is where you bear in mind in terms of the space that's going to be measured, where how you select. So for example, within the building, you want to work with a particular room. And further to that, even within that specific room that you have now selected, you probably have to look at doing your sampling at a particular spot, a specific spot or area within that room that you have selected. Another thing, area rather, that the standard points us to is looking at parallel measurements. So we need to bear in mind that there is a constant exchange of indoor and outdoor air, and we need to be cognizant of this. And we might even have to factor in what is going on with the weather conditions when you're doing your measurements as well. The next slide basically points us to the reference annexes, which looks at sources of air pollutants, sources of indoor air pollutants, the examples of substances and information to be recorded during your measurement exercise. So to bring all of this together on the next slide, the scope in itself is basically summarizing the standard, what it covers in terms of the planning for indoor pollution, the monitoring, where you develop a suitable sampling strategy, but also taking into consideration why you are doing this, when you are going to do it, the frequency in terms of doing it also, and consider also what is going on within the indoor space that you are working with. And it also covers, I think on the next slide, the spaces to which the use of this sampling strategy is applicable to. So when we look at this, it even speaks specifically to the types of building, the spaces within the buildings, and it also makes reference to vehicles as well. We spend a lot of time indoors, whether it's in our offices, we drive around quite a bit, especially when traffic is heavy in our vehicles. So these are some of the areas that we can look at when we are considering the sampling strategy that exists under part 1 of the 16,000 series. I will, in the interest of time, quickly continue with part 19, I believe is the next one. Thanks. That covers the sampling strategy for moulds. I'm sure a lot of St. Lucians are very familiar with this word, especially within our office spaces. So this part 19 of the 16,000 series is basically looking at the sampling strategy for moulds. Again, within the standard, the sections provided with regard to the introduction. Again, here, you're going to find the general details of the standards and, for example, the relevant annexes. We'll come back to the scope again because this is very important and this basically wraps up everything. So we'll continue with the previous slide, no need to change a slide. Again, we have some normative references here. I think there are 2. One speaks to the detection and enumeration of moulds, one by filtration and the other by impaction. So we need to bear these references in mind as well. For the avoidance of doubt, to avoid any misinterpretation, there is a detailed section in terms of the various terms and definitions that apply to the use of these standards. In terms of the properties, origin and occurrence of moulds in indoor environments. This points us to the possible causes of moulds, the dispersion factors, among other issues that we need to be cognizant of when we are developing our sampling strategy for moulds. Again, there's another section that speaks to sampling and detection methods. And again, this is going to depend on the purpose of the investigation that you're undertaking. And you are also within this section pointed to other standards for guidance on how to collect this to make sure you apply the best methods and procedures. The measurement strategy in this section quite a bit of detail there, but basically with respect to the general aspects, this looks at the conduct of analysis to detect, to locate your mold sources that you want to sample. And also in terms of selection of the appropriate procedure, this captures basically the most appropriate procedure to be used, again, depending on what prompted the investigation. The quality requirements and uncertainty, again, this is something that you need to pay attention to in terms of bearing in mind because of the varying characteristics of mold spores, then you need to factor in, the levels of uncertainty within your measurements and analysis. There are 3 annexes which support this standard, basically pointing us to moisture indicators, the devices to be used, and also in terms of field inspection and the relevant information to be documented. We will, for part 19, basically wrap this up in terms of understanding what the scope of the part 19 of this sampling strategy for molds entailed. So basically, with regard to the scope, this standard covers measurement strategies, sampling, analysis methods. You need to note that it does not cover building characteristics, and it does not cover the assessment of occupants within that building. This is a whole different exercise in and of itself. And essentially, to conclude, the part 19 is designed or structured so that it references or has its base in the next slide in terms of part 1 that we just went through for the general aspects of sampling strategy under the 16,000 series. So I believe, colleague, I hope I have enlightened you in terms of what is contained in parts 1 and 19 under the ISO 16,000 series as they relate to indoor air quality. And I'll hand over to my colleagues.
Thank you very much, Annette, for that brief intro. And we're moving right along. We will now have Ms. Ermin Herman, who will be going through parts 20, 30, 32, and 40. And we're still keeping with the indoor air quality. Part 20 speaks to detection and enumeration of modes and determination of total spore count. Part 30 speaks to the sensory testing of indoor air. Part 32 speaks to investigation of buildings for the occurrence of pollutants, and part 40 speaks to indoor air quality management system. Ms. Ermin Herman.
Thank you for this. Good day, everybody. It is going to be generally the same methodology as Annette has adopted. For the detection and enumeration of molds, this standard looks at the introduction, the scope, terms and definition, principle of the method, the apparatus to be used and the materials to be tested, the reagents, and one of the main reagents when you do a total spore count is lactophenol blue solution via direct microscopy. The procedure looks at the sampling with respect to how the samples are collected for analysis, be it surface, be it air sample, be it swabs, and how you analyze it via direct microscopy. It also speaks to how you calculate and how you express the results of your analysis. Another aspect is transport and storage, because that is important to maintain the efficacy of your sampling. Quality assurance, how do you ensure your client that you are producing valid results that they can trust? How to calibrate the flow rate of your testing equipment, especially if you're doing total fungal counts, and that has to be via spore trap analysis or because you would not do culturable fungi in that aspect. So function control and maintenance of your sampling system, which is very important. A sampling protocol, which has to be developed prior to the actual analysis. What are the performance characteristics? And there are two annexes associated, an informative and a normative. The informative will look at the different type of impactors that are used to collect mold samples of the air for total spore count. And the normative will look at the sample exchange for method validation. So as we are saying, the scope, which will give you a broad idea of what this standard covers, it specifies requirements for sampling of molds from the air. Following the instructions given, samples are obtained for microscopy to determine the total concentration of spores. Part 30 looks at the sensory testing of indoor air, and many persons would wonder why, but we're looking at generally this standard looks at putting together a group of individuals whom you would call your panel, and they would use their olfactory sense, the sense of smell, to determine the quality of the indoor air. It is not a method that is broadly used, but the standard really speaks to exactly how to go about doing it. So it covers the introduction, the scope, there are a couple normative references, terms, definition, symbols, the objectives, the principle, and it goes into really in-depth detail of the principle of the evaluation of indoor air, how to use the sensory test method, how to measure, plan, and what are the requirements of that measurement planning, and how to conduct the experiment. It is not a standard for one individual to just come in and smell the air. For those of you who have actually gone through that, that standard, it does not speak to just smelling of the air, but it speaks to applying certain rubrics and measurement guidelines to assess the quality of the air via sensory testing. So it also has the assessment and documentation aspects. For annexes, it actually goes into detail in the training procedure for the intensity assessments. And like I said, it uses a comparative scale. So how do you train your panel to use the scale to ensure that you're getting valid results? The training procedure, the verification of the olfactory function. So you need to ensure that the individuals you're going to use for this assessment actually have a good sense of smell. So you need to test that before commissioning that panel to do that assessment. The description of one possibility of a sampling and presenting device for air samples out of emission chambers. So another aspect is to have, it's not only about bringing in those individuals into the space for the sensory testing, but it also speaks to collecting an air sample in an odor-free container. It describes how you're going to collect that sample in that odor-free container, transport it to the lab, and then have the sensory testing done. And the final annex speaks to the example for the setup of a comparative scale. So the scope again just summarizes everything that we have said. Specific sensory testing and the evaluation of indoor odors using human panels. Sensory testing can be performed on site or in laboratories, in the latter case by means of air in sampling containers which are collected from the site. The olfactory testing is appropriate for office and admin buildings, assembly halls, residential buildings, and other habitable rooms in which the comfort and health of the occupants is of interest. You should also note that it is not applicable to factory buildings and workshops or other rooms in which odors are produced, for example, kitchen, bakeries, because they either will mask the odor of the issue, or it will produce or enhance the odor of the issue. So it is only limited to specific areas. If an odor evaluation is undertaken without the odor producing processes, it is necessary to take into account that there is a possibility that the processes have influenced and changed the odor, just like I have stated prior. Sensory odor tests of indoor air can meet a variety of objectives, and these would include finding the causes of the odor, determining the reasonability of odors, and the usability of affected rooms, and inspecting the results of renovation work. So you can use this scope for pre-assessments or post-remediation assessments. All right, okay. So when seeking the cause of odors, it is wise to conduct additional laboratory tests. So you are not going to be using this standard as a standalone standard for indoor air quality, but you have to use it alongside other standards to confirm or to validate the results of your sensory panel. A risk assessment is intended to be carried out to clarify that no harmful compounds are present in the room prior to the assessment. So the next one is investigation of buildings for the occurrence of pollutants. So as usual, introduction, scope, your normative references, terms and definitions. It speaks to the type, origin, and causes of pollutants in buildings, and we can understand that it is very important. And this does not, if my memory serves me right, I'm just trying to pull up that standard. Right, so normally we would look at just mold as being a primary pollutant, but there's so many other pollutants that can negatively impact on indoor air quality. So this standard would speak to that. And it speaks to how a methodology for undertaking the investigation of those pollutants and what are the phases of those of this pollution investigation. How do you produce a report and document your findings? That is covered in this standard as well. The annexes, the example of an investigation of pollutants, the VOCs, which are the volatile organic compounds. These compounds have very low boiling points, so they become easily present in the air, the VOCs and the possible sources, and the building related VOC sources. Sampling plan for the pollution investigation, which is very important. It gives you an idea of how you're going, because you cannot ad hocly visit and test a building without planning, prior planning. Sampling record for investigation of pollutants in buildings is another informative annex within this standard. So the scope, it specifies the requirements for investigating buildings and other structures and the technical installations for the occurrence of pollutants as a basis for subsequent sampling of suspect areas and determination of the type and the quantity of pollutants, which are described in other parts of the standard. Indoor air quality management systems, and I think this is an especially important standard for our indoor spaces today. As usual, normal introduction, scope, normative reference. So these are the topics covered within the body of the standard. We can move on. Operation, performance evaluation, and improvement. The annexes will look at identifying and assessing indoor air quality aspects and identifying and assessing indoor air quality aspects with a descriptive system flowchart. So this standard does not only look at just one aspect, but it looks at how do you create a management system and not do just a one-off assessment, but how do you incorporate or find relative persons and empower these individuals to ensure that indoor air quality is managed on a day-to-day basis. So the document specify requirements, like I said, for a system, establish a system of management of the indoor air quality, implement, maintain, and improve the indoor air quality management system. It ensures conformity to the indoor air quality management system, and it demonstrates conformity to this document. It is applicable to the indoor environments of all kinds of facilities, installations, and buildings, except those that are exclusively dedicated to industrial and/or agricultural activities, because this would require a totally different management system because of the type of activities that would happen there. It is applicable to all types of indoor environments occupied by all kinds of persons, including regular users, clients, workers, etc.
Okay, so at this time, I would like to introduce Ms. Cheryl Saint-Romain, who will be doing the standards for building environment design. And there are only 2 standards under this series. And these standards are ISO 16813, building environment design, indoor environment, the general principles, and 16814, which is indoor air quality, method of expressing the quality of indoor air for human occupancy. Ms. Saint-Romain.
Thank you. Are you seeing me? Thank you, everybody. Good morning and Happy New Year to those I have not seen. Like Mrs. Joseph said, we're looking at two standards, and she indicated what they were. But even before I begin, I want to give a definition for built environment. This refers to the human-made surroundings that provide a setting for human activity, ranging its scale from buildings, parks, and green space to communities, cities, and can include supporting infrastructure such as water, supply, road, and energy networks. The design and construction of the built environment or the building impacts the quality of the indoor environment, and that is noteworthy. As was the process before established, these 2 standards would look at the first one, introduction, the scope, normative references, terms and definitions, fundamental design processes, development design criteria, development of design aids, cost evaluation, and the 2 annexes, which looks at the normative and informative flow diagrams and design process. The scope, this international standard establishes the general principles of building environment design, taking into account healthy indoor environment for the occupants and protecting the environment for future generations. And like I indicated, and I deliberately highlighted what that definition, because what has been happening now, and we know we have been inundated, especially in our offices, with persons complaining of IAQ, poor IAQ conditions at the establishments. And what has been happening, or through our investigations, what we found is that a lot of buildings have been retrofitted. Buildings that are not designed for specific activities are retrofitted. The layout of the buildings have a lot to be desired. Also, the equipment that are placed in those spaces can contribute to poor indoor air quality. So the international standard establishes the general principles of building environment design, taking into account the healthy indoor environment for the occupants and protecting the environment for future generations. This international standard promotes an approach in which the various parties involved in building environment design collaborate, and that is important, with one another to provide a sustainable building environment. The unique features of the design processes are articulated by the following aims. And the aim is to provide the constraints concerning sustainability issues from the initial stage of the design process, including building and plan cycle, together with owning and operating costs to be considered at all stages of the design process. Also to assess the proposed design with rational criteria for indoor air quality, thermal comfort, acoustical comfort, visual comfort, energy efficiency, and HVAC system controls at every stage of the design process to make iterations between decisions and evaluations of the design throughout the design process. The building environment design involves not only architectural design associated with environmental quality, but also environmental system design associated with effective controls. This international standard is applicable to the building environment design for new construction and also, and more importantly, the retrofit of existing buildings. The next standard, which is the methods of expressing the quality of indoor air quality for human occupancy, it looks at the introduction, as was mentioned, the same criteria, introduction, scope, normative references, terms and references, methods of expressing indoor air quality. And that is general, method based on health, which is very important, method based on perceived air quality, method based on the ventilation rate, conformance, and the design process. Design brief parameters and assumptions. It looks at the objectives, which is important, the constraints, determination of the basis of the indoor air quality target level. And the annexes, the informative looks at the sources and control of indoor air pollution, methods of expressing indoor air quality, and examples of WHO air quality guidelines. Continued informative looks at emissions from building materials, and I mentioned that earlier, air cleaning devices, HVAC equipment as a source of pollution, and also ventilation effectiveness. The standard is intended to specify methods to express the quality of indoor air suitable for human occupancy, to allow several acceptable targets levels of indoor air quality depending on local requirements, constraints, and expectations. And it also applies to the design of new buildings and the systems and the retrofit of existing buildings and systems. It looks at the indoor environments where the major concerns is that of human occupants, the buildings having any combination of mechanical and natural ventilation, and the commercial and institutional buildings. Unfortunately, it does not apply to residential buildings, industrial buildings, and hospitals, although those parts of such buildings are similar to commercial buildings to be covered. And I say unfortunately because we receive complaints from all these areas as well, especially to the latter part of last year, we had quite a number of complaints from residences. So persons, the environment, the design, the material that are used in constructing homes can contribute to poor indoor air quality. The requirements of this international standard might not achieve acceptable indoor air quality for all people in all buildings due to one or more of the following sources of uncertainty. And that's important to note. The outdoor air brought into the building can be unacceptable or might be adequately cleaned or might not be adequately cleaned. That's very important. Indoor air has a wide diversity of sources and contaminants. There are many factors that affect occupant perception and acceptance of IAQ, such as air temperature, humidity, noise, odors, lighting, and psychological stress. There is a range of susceptibility and preference in the population.
The standard we're looking at will be presented by the chairman of the committee, Mr. Hubert James, and it is on workplace air, the general requirements for the performance of procedures for the measurement of chemical agents. Mr. James, I pass the floor over.
Good morning, everyone, and those I have not seen for the Christmas and the New Year. So I wish everyone health, prosperity, and success for 2021. I think that my task is the easiest task now because all what has to be said and the measurements and the procedures has been outlined by the previous presenters, and especially Ms. Sandrumin. Thank you very much for that to have made my task much easier. And may I say that when we talk about the equality in the workplace, I remember working at the Treasury, and they were going to computerize the Treasury. And they put all these big computers in the office, by the time the big ones they had, and it was generating a lot of heat. And then they started to air condition the place. I said, but we used to have all this natural air in the building before. And they said to me, the conditions have been put there for the staff, it's been put there for the machines. So they were more concerned about the machines they were put inside there than the staff who would be working the machines. So therefore, problems begin to arise as time goes by of air quality and moldings and everything starts begin to appear because of the changes, and they didn't take into consideration the human aspect of the workplace. So therefore, the presenters before has made my task much easier, and I'm supposed to look at the workplace a general requirement for the performance of procedures for the measurement of chemical agents. And it's DNS ISO 2581 of 2016. So therefore, all has been said. So I can just go through the slides, which is the introduction, scope, the narrative references, terms, and the definitions. We move to classification. We have general, screening measurements for time or weighted average of concentration, periodic measurements, screen measurement of variation of concentration in time and of scope, measurement for comparison with occupational exposure limit values. It will continue with general requirements, performance requirements. It's a general screening measurement of time, weighted average, concentration. Screening measurement of variation of concentration in time and scope. Performance requirement continues. Measurement for comparison with limited values and periodic measurements. And we are looking at ambiguity, selectivity, averaging time, measuring range, expanded uncertainty, chemical agent value, where compliant methods are not available. We look at the composite procedures, transport, handling and storage, environmental condition, description of measuring procedures, dimension results, additional requirements. Then test methods, validation report, then Annex A, we're looking at the structure, on informative structure. We're looking at the structure of measurement of description of method description. Annex B, informative, and we look at calculation of uncertainty of measurement. So these documents specify general requirements, performance requirements for procedures of the determination of the concentration of chemicals agent in workplace atmosphere. These requirements apply to all steps of measurement procedures general, regardless of the physical form of the chemical agent. Look at gas, vapor, airborne particles, measuring procedures with separate samplings, analytical methods, and direct reading devices. These documents specify requirements that have to be fulfilled by measuring procedures when tested with prescribed laboratory conditions due to a wide range of environmental conditions encountered in practice.